Yeah, okay. So let's get started. I should introduce myself first. So I'm Ryan Dawson. My title is Principal Data Consultant. I work at ThoughtWorks. So I work with a range of different companies, mostly on a work related to how to get most value from their data. So quite often this is big sort of architectural questions about how to structure their systems and the data to get most value from it. And that's one of those topics that we're going to get into today with data mesh. So data mesh is the big new paradigm in data architecture, and it's kind of like microservices, but for data. In this presentation, we're going to see what that means. So I'm going to actually try and explain what data mesh is and why it's like microservices for data. But we'll also look at what tech is available and try to get a feel for what data mesh can look like in practice, and understand some of the challenges involved in building a data mesh. I think we'll have enough time in this session also to look at how to evaluate whether data mesh is the right approach for you. At least we should do if I go fast enough. You're welcome to post questions on the chat, and I'll either get to them, I'll either address them when I see them, or I'll take them at the end, depending on whether I see them or not, really, and what the question is. Okay, so you've probably heard a bit about data mesh. It's okay if you hadn't, but it's quite likely that you either have or you will be hearing about it soon, because it really is the next big thing in data architecture, and there's a lot of hype. I've counted like loads of talks at conferences every time I've been around conferences recently, and as a consultant, I'm seeing a lot of organizations looking to do data mesh. But there's a lot of confusion about what the most important parts are and how to make it work in practice. So let's understand the essence of data mesh and what's involved in applying these ideas. First, let's talk about what problems data mesh solves. So we can understand data mesh as a response to certain problems in current data architectures. Popular data architectures tend to be centralized and monolithic, with one team looking after lots of different types of data, and often in just one place, like a lake or a warehouse. The pain points we see with these architectures are generally connected with a central team becoming a bottleneck, or the central tech becoming a constraint. What often happens is that the team can't keep up with the details of all the data, and they just simply don't have enough time to properly collaborate with all the operational teams who maintain the systems where the data comes from. So what you end up with is bad data, broken pipelines, and the central lake or warehouse becomes a place where the data just goes to die. Data mesh diagnoses the problem with monolithic data architectures as aligning data architecture around technology and not business needs. So instead of having a data warehouse team or a BigQuery team, we see teams in data mesh aligned to business domains. This enables teams to really know and own the data and make decisions with more autonomy and ultimately deliver more value. The big problem with the monolithic architectures is that they don't scale well at the people level. Centralization either creates bottlenecks or it creates too much distance from the data to be able to really get full value from it. Data mesh offers a way to scale both the technical data ecosystem and the people that create that ecosystem. Maybe these themes seem familiar to you: centralized monolithic technology and tech-aligned teams moving to decentralization, domain alignment, and empowerment. These are key themes of microservices, right? Well, there's certainly important parallels between data mesh and microservices. Just to make the microservices parallels super clear, we're talking about moving from centralized monolithic architectures like data warehouse or data lake to a distributed ecosystem. The distributed ecosystem can be polyglot, meaning that teams can choose whatever technology fits their use case. Think of how in a microservices architecture, teams are able to choose the most suitable language and library. Likewise, data mesh lets teams choose to use the best type of data storage for their use case, rather than having to use the lake. And domain alignment means that you don't have a data warehouse team or a UI team or a backend team. Instead, teams are devoted to a specific business area, like customer onboarding or stock and order or marketing. Perhaps the most important thing that microservices and data mesh have in common is that they're both architectural styles with wide-ranging implications for the organization. Zhamak Dehghani, creator of data mesh, describes it as a socio-technical approach. It's not just about technology or systems design, it's also about organizational structures, governance, and culture. Actually, it's often the softer sides of data mesh that prove more difficult for organizations to get to grips with. Likewise with microservices. Microservices are useful for comparison for data mesh, but there are also differences. All architectural decisions involve trade-offs. Here's a great way to think of the core trade-off of microservices, courtesy of my ThoughtWorks colleague, Chris Ford. If we break things into small pieces, we can change them independently, so long as we don't mind the added integration complexity. The so long as we don't mind bit here is important. If you break things up, then there's a bit more cost to making the pieces work together. The data mesh trade-offs are a bit different. Here, the data mesh trade-off is, if we dissolve responsibility for data to the people who produce it, we can rapidly incorporate new data sources and use cases, so long as we don't mind distributing skills and investing in self-service infrastructure. Again, the so long as we don't mind bit is important. We're breaking things up again, but what we're breaking up now is mostly people. So you're going to have data engineers in a load of different teams rather than one big team. That means you need ways for them to connect with each other and be aligned with each other. You might also have a larger demand for data engineering. So you want to try to lower the bar for what skills are needed to be effective as a data engineer. That's the point of the self-service infrastructure here. You're going to be spinning up lots of different data products. So you need to make that easy to do and easy to do in a standardized way. So let's get into the detail now about what it means to implement a data mesh. Let's start with data products. A data product is not simply a dashboard or a report or a data set, though these things can be parts of data products. The data product isn't just a specific analytical output, but also everything that's necessary to make that output happen. It's the data storage and processing code, the transformation logic, the code that handles reading in the data, the documentation that people use to find out what the data product offers, and any metadata that the data product exposes so that it can be discovered on the mesh. The data product should be focused on a specific business function. It should have a core use case. And the data product should be implemented in a way that is consistent with the rest of the mesh. Here's another view of what a data product is and what it contains that reveals how much variety there can be to data products. There are common elements shown here: the input layer, the output layer, the processing layer, and governance. But there can be a lot of variety about each layer. The inputs to the input layer could be an operational system, or it could be another data product, or it could even be an external data source like a public data set. It could be that the data product calls an API to get its data, or it might read from a stream or read as a file as a batch job. The processing layer can have a lot of variety too. The computation might be in Spark or Airflow or in a SQL database or a different kind of database. And there might even be some machine learning thrown in there. The output layer can have a similar variety to the input layer. There might be streaming or batch or an API or multiple outputs. Governance features in a data product are easy to overlook. The data product might expose metadata for discovery and for showing its listing in the catalog of of all the data products. It might also expose quality and performance checks, as well as logs to indicate the data product's health. Here's a view showing an arrangement of data products. This one from the original data mesh article by Zhamak Dehghani on modernfabric.com. This shows how data products can be divided up and how they can relate to each other. Here we see 3 different domains for a music streaming company. There's the artists domain on the left, podcasts and users. Podcasts on the top right and users at the bottom. In the top left, we have operational systems to onboard and pay artists. These 2 systems together feed the artist's data product. which can offer insights on which artists have been which artists have been earning the most in different time periods. At the bottom, we have the users domain with a single operational system for user registration. The user profile data product is fed by that one operational system. It has two output ports, one for monthly summaries of user profiles and one for feeding user profile updates, say as a live stream. So we see here that data output ports can be live feeds at a record level, or they can be aggregated data on a schedule. The stream of user profile updates is consumed by a data product in the podcast domain up in the top right. The data product up here in the top right takes input from two operational systems, and one is in the podcast domain and the other in the users domain. So we see here the data product can also belong to a certain domain, but still take data from different domains. We're now going to move towards what capabilities you need for a mesh and for the data products on the mesh. But to get there, we first need to recap the 4 principles of data mesh, because the capabilities that we need will flow from these principles. The first principle we'll look at is domain ownership. We've talked about this a bit already, and we've seen it in the previous example for the music streaming company. This one is mostly about how you organize your teams and identify and carve up your data products. It's a super important principle, but actually the other 3 principles have more implications for the capabilities that we need when we go about building the data products and building out the mesh. So we're going to skip over this for a bit and move on to the next principle. Data as a product works hand in hand with the domain ownership principle. Teams need to be given autonomy and allowed to get close enough to the data to really own it. This enables the team to handle the data as a true product and not just as data filed away and forgotten. The autonomy side of this means you need a variety of tech to be available for implementing data products. You can't just impose the same database type on every data product, for example. And treating data products as products means teams are empowered to delight their consumers. So data products will have capabilities to expose data in various ways and report on their quality and expose high-quality documentation that explains the meaning and origin of the data, as well as its format. The self-service platform principle is about empowering data product teams and also enabling some standardization. This provides a foundation for the mesh implementation, like a soil that can help all the data products to grow. The platform should provide ways to bootstrap new data products. This could mean providing templates or starter kits. Or for an advanced mesh, there might be a dev portal with a wizard that provisions with resources using templating. We've mentioned in the other principles that data products should be easy to find and that there should be standards and policies holding them together. The federated governance principle makes this explicit. Part of this principle is also about people and culture. Federated governance is best coordinated using a governance board with representatives from a range of data products and other interests. So it's quite different from the centralized and top-down model of governance that many of us are familiar with. Federated governance also has implications for the capabilities in play in data products and in the mesh. You want all data products to be findable in the same way and from the same search facility. You want them to use a common format for reporting their quality and monitoring and any audit trails. So this slide brings together the capabilities we've just talked about and breaks them down by principle. At the platform level, there's provisioning of resources using templates or wizards in a dev portal. For good governance, we want a catalog. And the catalog can make all the data products visible to potential consumers. We also want standards and policies and monitoring tools. For data product teams to have autonomy, we want a variety of data storage tools and technologies and formats for input and output ports. There may also sometimes be specific integrations that apply to data product interactions or which cut across multiple data products, such as federated query or data virtualization. Now, let's think about how these capabilities fit into the user experience of the mesh. There are different user experiences for different personas interacting with and working on the mesh. It's helpful to think of the mesh as having different planes aimed at different user personas. For data product developers, there's the data product experience plane. This is a kind of platform where data product developers can find other data products to connect to and tools for bootstrapping new data products. This platform has to be built out of some underlying tools, and somebody has to build it. The somebody that builds it is the data platform developer. They build the data product experience plane using tools from the platform infrastructure utility plane. Or if you don't have a data product experience plane, or it doesn't have everything that data product developers need, then they can go straight to the platform infrastructure utility plane. Let's get a bit clearer on what a data product experience plane can be like. Imagine you're a developer building a data product. The platform would give you a way to say that you want one graph database for storage, a Spark instance for doing your extract, transform, and load, and also permissions to load specific files from, say, S3 as an input from another data product. Then the platform would bootstrap the resources for you and apply further templating to give you a skeleton of the endpoints for discovery of the data product and exposing metadata. Or maybe you choose a different set of options, like a MongoDB database instance instead of a graph database, or different kinds of output ports. If we're lucky data product developers, then maybe we'll get a UI with a wizard to help us out with this. There are developer experience portals for microservices, which are a lot like this. Spotify has one, and they've open sourced the foundation of it as Backstage. Actually, Backstage isn't a portal so much as a starting point for shaping your own in-house portal. Developer portals like the ones you can build with Backstage enable developers to use templates to bootstrap new microservices and pick from a curated set of technologies. Unfortunately, there's no off-the-shelf equivalent available for data mesh right now. So to build a data mesh experience plane with a smooth UI experience like this, then you have to build a lot of it yourself. So we've talked about the two planes aimed at data product developers and data platform developers. There's one more plane left. The top level plane is an experience plane for consumers of the mesh. The data analysts and data scientists and business analysts. This is a very different audience with a different set of needs. They want to find data products, understand the data, understand the format of the data, request permission on data products, and ultimately use the data products to answer questions and solve business problems. You might now be wondering whether you need all these capabilities. The answer is basically, it depends. Meeting all of these capabilities can be a lot of work, and actually not every mesh needs every capability. There's no definitive, you're not a data mesh if you don't have this list. But if you don't have any of the capabilities that we've talked about, then it really isn't a mesh. And you could think of this as similar to the question, like, is this thing really a microservices architecture? You know, it's often quite hard to answer that question. Off-the-shelf tools and platforms can ease the burden. But it's not exactly easy. We'll get into that now. The challenge with all the off-the-shelf tools is, or one big challenge with them is it's not easy to pick which ones. There's a lot. And it takes time and expertise to understand what they all do and how they relate to each other. The logos in this slide are just a selection of platforms and tools. If you look at the MAD landscape, published by Matt Turk, there's just way more. This is a tiny little section. I have attempted to put some order on the chaos and have set up some tables in a GitHub repository. The link is here at the bottom of the slide, and I'll aim to share it at the end. If I don't, then please remind me. The table is looking at features of commercial data platforms, but the feature categories roughly correspond to the categories of standalone tools. And the GitHub repository has details of all of these standalone tools too. Now, we don't have time in this session to go through all the details of everything. What we will do is just go through some key categories and understand how tools in these categories can be useful for data mesh implementations. Let's start with a quick look at the data catalog or data discovery category. Basically, a data catalog is an index of what data the organization holds, where all of it is, and metadata about the data. This makes the data findable and usable. The catalog may have some discovery or crawler service for finding data, but typically data can also be explicitly registered. Having data products register themselves fits better with a mesh philosophy than using crawlers. And this way of ownership of catalog data is, or that's because this method puts the ownership of the catalog data on the data product. Once data is registered, then users can search for it. If a user of the catalog finds data they want to access, then they need to go through some permission request flow. Setting permissions for datasets and even tracking the lineage of datasets can be a data catalog feature. Or sometimes platforms have permissions and lineage as a distinct concern separate from the catalog. Either way, these are capabilities you're going to be looking for, as allowing users to discover and request access to data is a key feature of the mesh experience plane and a key capability of a mesh under the federated governance principle. Now, a key challenge with data catalogs can be that there's a range of supported sources and interoperability, and this makes it awkward to achieve interoperability on metadata formats. Now, you can see why this can be challenging, as the data tools landscape is changing all the time, and catalogs have to keep up with all this change. Data can be in lots of different types of places, and in many cases, the tools hosting the data will have their own metadata formats. One open source project taking an interesting approach to this is Open Data Discovery. They're putting a big emphasis on their open specification for metadata. They're hoping that more projects will adopt this, or that adapters to it will be built, or adapters rather will be built. Now, I'm mentioning Open Data Discovery here, not in order to endorse them over other projects, but just to suggest that there's work going on in this space to try and make create better interoperability between metadata specifications. Now, I don't want to take sides, so I should mention that Open Lineage is another important project in this space. I'm just using Open Data Discovery as an example, which illustrates that collecting metadata from a wide and changing variety of sources can be a big challenge on the data catalog. This is important, as registering a wide variety of data sources and the metadata is also a challenge for data mesh implementations. I mentioned that permissions and lineage are key aspects of federated governance, and that these are sometimes capabilities of a data catalog. They might also be provided by other tools separate from the data catalog. The slide on here on the left shows a user choosing to share a dataset within Google BigQuery. Now, BigQuery isn't a catalog, but it has features to request access, and there's also a similar capabilities there to request access to a dataset or revoke permissions on a dataset. On the right is a screenshot showing a view of data lineage within Microsoft's Purview tool, which is, and Purview actually is a data catalog. Now, lineage is typically about tracking what operations were performed on the data, so that you know what history of actions led to the current state of the data. Here in the slide, we see that two CSV files were merged and then further combined with data from a database source. This history is basically metadata that you want to record alongside the dataset, so it fits naturally with the data catalog. If you're lucky, then your ETL tool might make this metadata easy to generate and might even integrate automatically with your data catalog. But as we've seen, there are challenges for data catalogs to handle the range of formats out there. So the integration will probably require some work unless you've gone for a commercial platform that has the integration built in. So we've seen how important it is to make data accessible and show consumers what the data means and where it came from. Data consumers need to know about the meaning, structure, and history of the data in order to figure out whether the data works for their use case. But just knowing this probably isn't enough to find out whether a data set will answer the questions that you want to answer. This is where data exploration tools come in. Among data scientists, Jupyter notebooks are especially popular and can provide a good environment for exploration. You can do a lot more in Jupyter notebooks than just exploration, but they're still good for exploration. There are also lots of other data exploration tools out there, and many of the big commercial data platforms have some sort of tool dedicated just to data exploration. The slide here shows AWS QuickSight on the right. That's one such tool. These tools tend to cater for data analysts and business analysts, as well as data scientists. A data platform naturally needs to provide data storage and a way to query data in the storage. Most platforms provide a lake or warehouse option, and some provide both. There are also hybrid lake and warehouse types of data storage available. Pretty much all the platforms provide ways to store, transform, and query both structured and unstructured data. Warehouse and lake storage are both likely to be needed by data products, and polyglot storage is a key capability flowing from the data as a product principle. It's worth noting that most platforms provide options for this, but not necessarily in a data mesh way that lets you easily define particular transformations as belonging to a particular data product. The polyglot storage aspect of data mesh also means that document, graph, and time series databases might find their way into a data mesh, even though these are much less common in analytical data stacks than they are with operational data stacks. Now, typically, data platforms have some sort of NoSQL option, but how many options and how mature they are can vary quite a lot from platform to platform. The cloud providers have most of these options, but that's really because the cloud providers are also catering for operational teams, and these databases are more common in operational situations. Data platforms that specialize in analytics are less likely to have these. Now, this can be an area where picking a data platform to support your mesh might not be quite enough, and you have to then bring in custom tools for particular cases. So we've seen that data product input and output ports may involve streaming of data. Actually, this is a very common way to do the input and output ports, as it allows for an event-driven architecture. So it's important for data product developers to have this available as an option, ideally provided by the platform. If your mesh platform is using an underlying commercial data platform, then you'll want at least one streaming technology option to be provided. And all of the data platforms that I've included in the GitHub repo do have a streaming option, though they can vary quite a lot in the details of how they work. The reporting and BI tools are easy to overlook, as I think many data engineers and data architects have a bias towards the back end. But building reports and dashboards is super important for data products and super important for getting value from data. The data product output ports need to be able to delight consumers. This is a key capability flowing from the data as a product principle. So that's some of the most relevant categories of data platform features and tools for data mesh implementations. There are more categories that I would have loved to discuss and go into more detail, but I think we've said enough to see that data platforms are useful. But we have to be cautious because what data platforms provide right now is not the same as the data mesh platform plane that will empower data product developers. There's nothing in these platforms like the wizard or templates to build the data product that we talked about as part of a data platform experience, though some platforms are starting to provide some templates. The fundamental gap is that these platforms have been designed around an idea of providing specific services and not data products. So to build a data mesh platform on top of a commercial data platform takes some work, and it can be awkward in places. There is an alternative to starting from a commercial data platform or product. You can simply start by selecting a range of individual tools, maybe a mixture of open source and specialist commercial tools. These can be curated and assembled, and a platform layer built on top of them. Naturally, it's a lot of work to get the platform experience that delights developers that we talked about earlier. The integration work can be tricky, as the tools probably weren't originally designed to work together in a mesh. Much like the services in commercial data platforms weren't originally designed to be used in mesh either. Let's now get a small taste of what some of the integration work for a data mesh platform can involve. I work for a consulting firm, ThoughtWorks, and we partnered with Saxo Bank to build self-service data infrastructure. Data Hub was the chosen data catalog, but at the time, there were limitations on being able to show quality metrics about datasets in Data Hub. So ThoughtWorks and Saxo contributed to an open source plugin that integrated a data quality tool, namely Grade Expectations, and to make that work with Data Hub. That open source plugin is now being productized under acryldata.io. Hopefully this gives a small flavor of where the tool's ecosystem is at right now with data mesh. On the one hand, that plugin has been developed and is now being productized. On the other hand, it wasn't available when we first wanted it, and that wasn't all that long ago. I think this example is also a good illustration of an integration which, when you start on a data mesh journey, it might not seem obvious that you need it. But when you think about it, you can see how valuable it is for inspiring trust in datasets to have those quality scores on there. Another challenge when implementing the mesh platform planes is how you create and maintain data products. You might have a picture in mind of each data product's resources as basically a Terraform project. But imagine you've got a wizard with options to create a data product where developers can choose their storage and input ports and so on. Then you've got a UI for the wizard, and that needs to call a backend API, and the endpoints of that API then need to have a spec for a data product. When data products change, you also want your platform plane to reflect that. You don't want to be showing a data product as having one output port when in fact it now has two. If you make that specification explicit, you're careful about your API, then you could also handle data product changes in a declarative infrastructure as code way. This is where the data product specification open source project comes in. It's proposing a format for describing data products. Hopefully a project like this catches on. Otherwise, every mesh implementation will have to invent their own variation of a specification like this. So we've seen that there can be a lot of work involved in setting up a fully featured platform plane to support data product developers. In some situations, putting in that effort up front may be overkill. Maybe you won't have all that many data products. Maybe they'll all be pretty similar. It can also be challenging to justify a lot of investment in the platform up front when you want to get early data products live to demonstrate value. In these cases, it can be okay to be pragmatic and provide a lesser experience to developers and users. I'd argue that there's situations where it's okay to have a wiki instead of a data catalog. It's not as smooth as a data catalog, and it puts much more burden on teams to ensure they document things in a consistent way. But it's usable, especially when there's only a few data products. Remember the data mesh promise. The investment required for self-service infrastructure is part of the trade-off. If we make the investment, then we can reliably devolve responsibility for data to a distributed set of teams who are close to the details. The more teams and the more data products, then the more we need to invest in self-service infrastructure. If we don't make that investment, then teams may struggle to get going, or they may build things that diverge more than we want them to. That's the trade-off. Before deciding to invest lots in self-service infrastructure, it makes sense to assess where you're going to get value from your data mesh initiative. At ThoughtWorks, we recommend undertaking an exercise to map out the key areas where business value could be unlocked and identifying the highest value data products. Then you can focus your initial efforts there to ensure that your initiative can get some big wins early on. In this presentation, I've mostly focused on the technical sides of data mesh, the platform capabilities and the tech available to implement. But it's important not to let tech questions become a distraction from the biggest questions of your data mesh implementation, which don't tend to be on the technical side of things. Remember the data lake and warehouse pain points that we looked at right at the beginning about a central data team becoming a bottleneck. That's an organizational pain point, and data mesh requires organizational change. That isn't easy to achieve, and you'll have to break down barriers in order to achieve it. Teams will meet resistance and challenges, and they'll question where things are meant to be going. You want to be as clear as possible about why you're going data mesh, what pain points it's going to solve, and which data products you'll get most value from. So hopefully we understand now that data mesh addresses certain pain points about scale, but it's not a fit for every circumstance. For certain circumstances, you may not have enough use cases. There are reasons to not go mesh. It might be that your use cases are not of the relevant types. So let's understand now about when you might mesh and when you might not mesh. So the number of use cases is a big element of whether to choose a data mesh or not. If you only have a small number of use cases, then this could be addressed by a central data engineering team generally. If you don't have the scale, then you probably don't have the organizational pain point of the central team becoming a bottleneck. And if it ain't broke, then you don't have to fix it. So then the investment in the self-service infrastructure could be overkill. And there's some more detail on how to do this kind of assessment of your data mesh suitability in Zhamak Dehghani's data mesh book, which I'm referenced here. So another consideration is whether you have the right types of use cases. You might have lots of use cases and large scale, but that still doesn't guarantee that data mesh is the right fit. Requirements have to drive the choice of architecture. Data mesh tends to fit best with cases where you need your analytics to feed back into operational processes or applications. So think live dashboards or interactive dashboards or reports. If your use case are basically all reporting use cases where analysts come up with answers or run reports on a regular basis to update management, well, that doesn't have so much pull towards data mesh. For those kinds of BI and reporting use cases, the data analysts can typically produce what they need for themselves as long as they're given the right access to the data. You don't then have, in those kind of situations, you don't have the kind of deep interrelationship between the operational and analytical planes. So you don't have so much need for domain-oriented data product teams who will be have to like learn up, gain that specialist knowledge of the data. Another argument against data mesh, or that might push against data mesh in a particular case, is that when you pull all the data apart, then how do you put it back together again? This objection is one that I hear commonly, and it can be a misplaced objection, or it can be a real objection in different situations. A lot of organizations are used to having all the data in one place. And when you've got all that data in one place, it can be quite tempting to sort of not pay that much attention to exactly who wants to do what with which data. The central team in this case just basically says, it's all here, do what you want. But for data mesh, you need to identify exactly what you want to do with it, what you want to do with exactly which bits of data in order to put the right teams in place and the right data flows in place. So data mesh forces you to identify use cases. Now that's a big cultural leap. So it can look like that there's this big objection to data mesh here, when in fact that objection might not really be valid. However, there are also use cases or situations where a problem like this, I like to call it a Humpty Dumpty problem, because you're taking everything apart, how do you put it back together again? So there's situations where this Humpty Dumpty problem is real. Sometimes the use cases for the data involve taking lots of data from lots of parts of the business. If the use of the data is heavily interlinked, then data mesh might not be worth it, because then you'd be expending a lot of effort putting the data back together for each of these data products, when actually, if you're just going to be joining up in lots of different places, then it might make more sense to have it all together to start with and build on that. Data mesh is not a silver bullet. It solves particular problems, but there are still cases for other data architectures like data lake, data warehouse, or data fabric, and so on. So data mesh addresses the problem of how to scale analytics at a people level. It involves a cultural leap, and that cultural leap takes us to the 4 principles with data as a product and federated governance and so on. Implementations have to choose how far to go with each principle. Self-service infrastructure, especially, can be a big investment, depending on how you want to do it. There is tech in the industry available to help, but the tech won't get you all the way without significant effort on your part. Data mesh is not a fit for every use case. And when it is a fit, you have to figure out what that fit means for you and how you're going to manage it. So that's my presentation. I hope that's been useful to you. Thanks for listening. As promised, the GitHub link is here again on the slide, so I'm going to paste that into the chat. And if you'd like to discuss the GitHub or anything else data mesh, then please do ask questions now, or feel free to grab me later, or get in touch via email or LinkedIn or whatever your preferred method is.